So let's begin by talking about simplifying radicals. Now, one thing we didn't talk about in the introduction that we need to understand is if I have, say, the square root of 25, that equals 5. But what if I had the square root of negative 25? Think about this for just a minute. What is our answer? Well, if I wanted to check our original, okay, the square root of 25, I would do 5 squared, right? 5 is our answer, square is our index, or our index is 2, not square actually, sorry. 5 squared, and 5 squared is 25, and we come back to this, okay? So that works. So what if we said that the square root of negative 25 is negative 5? Well, let's check that, okay? So negative 5 squared, and it has to be in parentheses, guys, because this whole thing is our answer. Well, what is negative 5 times negative 5? Well, that's 25. So that doesn't come back to our answer. And neither would 5, as we just saw a minute ago. So the answer to the square root of negative 25 is not a real, and this is very important, number. So for right now, whenever you have something like this, the answer is not a real number. Now let's be careful. What if I had the cubed root of negative 27? Well, the cubed root of 27 is 3, because 3 to the third is 3 times 3, which is 9, times 3, which is 27. So this could just be negative 3. Let's see if that works. Let's check this, okay? So this would be negative 3 cubed, right? Not equals. Negative. So that would be negative 3 times negative 3 times negative 3. Well, negative 3 times negative 3 is positive 9. And positive 9 times negative 3 is negative 27. And we just got back to our original. So negative 3 works. Now, what is the difference between the square root of negative 25 and the cubed root of negative 27, where the answer to the square root of 25 is not a real, and you need to use all of these words, number, and the answer to the cubed root of negative 27 is negative 3. What do you see is the difference? Well, let's talk about what our difference is. The index here is what? If it's invisible, it's always a 2. Remember that its name is index. And our index here is a 3. Well, this index is an even number, and this index is an odd number. So here's the difference. If we are trying to multiply an even number of negatives, it always comes out to a positive, and we can never, ever do it. We can never do this. It would be not a real number. Whereas if we have an odd number of negatives that we're multiplying together, we can always get back to a negative, because a negative times a negative times a negative times a negative times a negative, however many odd times you want to do that, will always be a negative. So be real careful. If you've got an even index and a negative underneath, so even index and negative underneath, the radical sign, then the answer is always not a real number. If it's an odd index, and a negative underneath the radical, the answer is negative. Okay? Now, I'm going to put one caveat here. For right now, if we have an even index and a negative underneath the radical, then the answer is not a real number. By the time we are finished with this unit, you will know what to do with that, and this answer, not a real number, will no longer be acceptable. So for right now, it is, and you will know when we get there when it is no longer acceptable. So what I'm going to do now is just a bunch of examples of doing simplifying radicals. Well, I could try and work really hard to come up with what number times itself 3 times would be 64, or I could just do prime factorization. 2 goes into this 32 times, 2 goes into this 16 times, 2 goes into this 8 times, 2 and 4, 2 and 2. And my index tells me how many of the same number needs to be in a group. Oh, and look at this. All prime numbers are circled. That means it's an even index, which means I'm going to come out with a whole number, nothing left over. If I were to put it in a calculator, there would not be decimals. So I take 1 from each group, multiply them together, and my answer is 4. Let's just check it real quick. Okay, that would be 4 to the third. So that's 4 times 4 times 4. Well, 4 times 4 is 16 times 4. Well, I don't know about you guys. That's 24. Oh, look at that, 64. It works. Let's do another one. Let's take the cubed root of 216. Well, again, I don't want to try and work my brain that hard. So 2, and that would be 108. 2 is 54. 2 is 27. 2 no longer goes in. So then I would see, does 3 go in? Because 3 is my next lowest prime number. Well, it does. 3 times 9. 3 times 3. My big boss says 3 has to be in each group. Look at that, an even root. So 2 times 3 is 6. So 6. Let's check. That would be 6 to the third. So that's 6 times 6 times 6. 6 times 6 is 36. I don't know. 36 times 6. 36, 18, 19, 21. It works. Let's just keep going. What if I was asking you about the 4th root of 256? Prime factorization. 2, 1, 2, 8. 2 times 64. 2 times 32. 2 times 16. 2 times 8. 2 times 4, 2 times 2. Big boss says 4 of the same number in each group, so there's 4 of them. And there's 4 of them again, a whole number, so 2 times 2 equals 4. So the 4th root of 256 is 4. I'm not going to check this one. You guys can do it. Let's try another one. The 5th root of 243. Geez, I don't know. So 243. 2 will not go into this one evenly, so let's see about 3. Well, remember adding up these numbers. 2 plus 4 is 6 plus 3 is 9. 3 goes into 9 evenly, so 3 will go into this one. I don't know how many times. 3 goes into 24, 8, and into 3 once. Let's see if 3 keeps going. 8 plus 1 is 9. 3 goes into 9, so 3 will go into 81. I just don't know how many times. 3 times 2 is 6, and that's 2 left over, so 21. 7. I know 3 goes into this, and 3 times 3. Big Boss says 5 in a group. Whoops. Well, that was weird. 5 in a group. 1, 2, 3, 4, 5. So the even cubed root of 5, the fifth root of 200, the even fifth root of 243 is 3. Again, I'm going to let you guys check that. All right, let's try this one. The fourth root of 16 over 81. Well, sometimes it'll be written like this, and I will want to separate it out because it's easier. And sometimes it might be written like this, and I'll want to put it back underneath 1 because I can do stuff first. I can't do anything with 16/81, so I separate this one out. The fourth root of 16, let's not do that. The fourth root, well, I don't know. Let's do this. 2 times 8, 2 times 4, 2 times 2. Big Boss says 4 in a group. So the fourth root of 16 is 2, and it's an even root, so there's nothing left over. So that means the radical sign is gone. 3 times 27. We just did this one a second ago, so, 3 times 9. I'm going to let you look above if you want to refresh your memory on that, or go back. 4, the Big Boss says, and so 3. So the fourth root of 16/81 is 2/3. Okay, let's just keep doing examples until I run out of time. So, negative the square root of 36. Well, the square root of 36, I won't do that. Square root of 36 is 6, and then negative times a positive is -6. That would be different if this were the square root of 36 like this, because this is an even index, remember, an invisible 2, and the negative's underneath, so my answer would be, I wish I'd stopped doing that, not a real number. Notice the difference here. The negative here is underneath the radical. Here, it's outside the radical. Okay? Let's look at the sixth root of -1. Well, this index is even, and my negative is underneath the radical, so not a real number. Before I forget, my computer cannot put the index in the V of the radical. So when I'm typing stuff on the computer, it's going to look something like this, or the fifth root of 243, or the third root of 5400, whatever. If this little number looks like an exponent type of thing and it's right outside, it means it is the index. It really belongs inside of there. Okay, I'm going to continue with more examples in the next one.